State-of-the-art radiation therapy increasingly relies on more and more advanced imaging for accurate target delineation. The RT Image Suite application offers you a comprehensive image interpretation environment for tumor contouring complementary to the functionalities you may have available in your treatment planning system. This movie will show you how to assess images as preparation for radiation treatment planning and segment the treatment target and other relevant anatomy in syngo via RT Image Suite. In this movie, we will show you how to perform 3 of the most typical use cases for contouring in radiation therapy. Let's start then with the first example, target contouring using multimodal images. The usage of multimodal imaging is particularly useful when the CT images do not contain enough anatomical or functional information to clearly assess tumor extension or activity. To gain additional insights for contouring, you may want to use additional imaging available for the patient and fuse it with the planning CT. To start, first make sure that the study is correctly assigned to the MMRT Image Suite workflow. Otherwise, right-click and select Open with MMRT Image Suite. The application will show a black screen asking you to load images. This can be easily achieved by dragging and dropping the image series to be loaded from the Series Navigator into the working area. To load additional images, select the image series to be loaded and holding the right mouse button, drag and drop the series into the image area. A menu option will appear offering the possibility to fuse the images. Add the images into the display area side by side or replace the image series on top of which you drop the images. The application layout will automatically change to adapt to the amount of images you have loaded. In this example, we will use a planning CT as the basis image and several MR sequences and a PET CT to support the contouring process. Usage of multimodal information may be required, as in this case, when the tumour is not visible in the planning CT or there are doubts on the actual tumour extension. After loading any image, the application will automatically register the loaded image to the leftmost one using a rigid registration. If a registration is already available, it will be used instead. You can easily change the registration by clicking in the upper left watermark or selecting the functionality in the Registration tab in the Case Navigator. Deformable registration is also accessible from the same mini toolbar. Once the images are registered, you can start with the contouring process. Simply select the contouring tool you want to use and select if you want to contour on the original image orientation 2D option or in any arbitrary orientation 3D option. In this case, we will use the 3D freehand tool to contour the tumour area on the MR images. Using the nudge tool, we will refine the contours drawn on the PET CT images. Note how activities performed on the contours simultaneously reflect on all views. You can change the name and display the color and type of structure in the RT Navigator at any time. The application provides semi-automatic tools for skin segmentation and PET threshold segmentation. In addition, you can use the tools available in the application to apply a certain margin to a given structure, combine different structures, or remove the overlap between structures. Saving and sending the structure set to the treatment planning system for plan optimization and dose calculation is as easy as completing the workflow by clicking the Save and Send option. In the second example, we will show you how to contour a lung case using an internal target volume method. This is only one of the many possibilities the RT image suite offers for contouring respiratory cases. The challenge in this case is to use all of the information contained in the temporal MIP and the individual respiratory phases to accurately contour the tumour, keeping the workflow simple and straightforward. We will start by loading the required images into the application. From the left to right, we will load the average CT, the temporal MIP, and the breathing phases. The average CT is needed as it is the data set where the dose is calculated. However, the extension of the tumour is sometimes not obvious when looking at this image series. To gain additional information, let's start by reviewing the tumour motion in the individual phases to ensure that no relevant artifacts are present in the images. For more comfort, you can change the image orientation using the orientation cube. Simply right-click on the cube and select the desired orientation for this segment. Using the 3D freehand tool, the full tumour volume can be segmented by simply drawing the tumour extension in two orthogonal projections. Using the 3D nudge tool, contours can be refined using the single breathing phase information. As in the previous case, all displayed contours change as soon as you perform any changes, but they will be saved for the planning CT. As you can see, the RT image suite allows you to visualize all datasets relevant for the 4D planning and efficiently contour and correct on any of them. This noticeably simplifies and streamlines the otherwise lengthy process of 4D contouring. Although we have shown you only the easiest workflow in this video, the RT image suite also allows contouring of every individual breathing phase. It also provides functionalities for propagation of the contours drawn on a certain phase to the other phases, as well as for creating an ITV based on the individual contours drawn on the individual breathing phases. This is just how it would look in the application after performing the contouring and propagation steps. Finally, in the third case, we will show you how the application can handle patient recontouring. This is typically done during adaptive therapy protocols or when the patient anatomy has changed during the treatment, as often happens with head and neck treatments. In such cases, after reacquiring a planning CT for the patient, you would need to recontour the patient anatomy. This process can be greatly accelerated by reusing the previously drawn contours. To perform this step in the application, simply load the new planning CT and, next to it, the planning CT previously contoured. To see the contours previously drawn, just change the display mode by disabling the contour reflection. Now you can see the contours you want to get copied to the new planning CT. The next step will be to deformably register the prior planning CT to the new planning CT. After this process, both the original CT and the original contours will be modified to match the new anatomy. Simply copy the deformed contours using the copy dialog, selecting as source the deformed old planning CT and as target the new planning CT. You can see the volume and position change by using the information dialog.